1, 2, 3. Remember, the surface currents are caused by the wind, and that wind is caused by unequal heating of the earth. Winds are deflected by the Coriolis effect. Surface currents are also affected by continents getting in the way of the movement. All of this makes the gyres, moving large convection currents in the ocean. On the western side of the gyres is a western boundary current, and on the eastern side there is an eastern current boundary. The western boundary currents, WBCs, are found on the western side of the gyre, but the eastern side of the continent. There are the Gulf Stream in the North Atlantic, the Kuroshio in the North Pacific, Brazil Current in the South Atlantic, East Australian Current in the South Pacific, and the Agualas Current in the South Indian Ocean. These are narrow streams of strong poleward flow that transport warm waters into the mid-latitudes, our area. They exist on the western boundaries of the great subtropical ocean gyres off the east coast of North America, Asia, South America, Australia, and the southern Africa. There are no such intense currents along the ocean's eastern boundaries. Western boundary currents are among the largest and the strongest currents and typically move 25 to 75 miles per day. These currents also extend much deeper than most other surface currents, down to a depth of about 3,300 feet or more. Because of the strong western boundary currents are so deep, they are deflected by the continental margins, which prevent these currents from flowing onto the shallow continental shelves. Western currents warm the east coasts of the continents that they come in contact with. Eastern boundary currents, which flow from the high latitudes to the equator, are slower and shallower and wider than the western boundary currents. Similar to the return flow in a household heating system, these currents transport cold waters into the tropics at about 3 to 5 miles per day until they reach the equatorial waters, where they are heated again and transported poleward in the westerly boundary currents. Eastern boundary currents cool the west coast continents that they come in contact with. The California Current, EBC, East Coast Boundary, is shown on the left. It flows southward along the California coastline. It's located 40 to 100 miles off the west coast of North Africa in a range of blue, green, and yellow. On the right is the Gulf Stream, a WBC, West Coast Boundary, in yellow and orange, revealed through sea surface temperature data. Compare this image to the Western Boundary Current image. Notice that California Current has cooler water temperatures than the Gulf Stream Current. The Gulf Stream is easily visible as the warmest water in the image. Currents are critical to marine life. Cold water contains large amounts of nutrients that feed the base of the food chain. This is great when cold water full of nutrients mixes with warm water full of living organisms like plankton and small fish. Many warm water animals that favor these boundary zones, such as tuna, swordfish, and squid, are particularly important commercial resources. So understanding how and where ocean waters mix gives fishing fleets the ability to locate schools and minimize their time at sea. It also gives marine biologists information that they need to help manage the fisheries or protect endangered species. The current forms kind of a fence line of changing temperature and velocity in the ocean. Mats of seaweed gather there. Bait fish cluster under the cover, attracting large predators. The whole food chain is there. Marlin and other billfish, normally found in deeper water, will roam the edges of the stream and its eddies in search of prey, along with tuna and dolphin. Boundary currents are highly productive regions. The process of nutrient supply to surface waters is different in the EBC and the WBC systems. Look at this image of global productivity. Colors correspond to the surface chlorophyll carbon content. The red end of the spectrum is the highest productivity. Blue and violet end is the lowest. The overall pattern with latitude is clearly visible. Low productivity in the tropics and subtropics, probably due to nutrient limitation brought about by strong year-round thermoclines and pycnoclines. High productivity in the higher latitudes. Regions dominated by eastern boundary currents have prevailing winds that blow offshore, pushing away surface water and allowing deeper, nutrient-rich water to come to the surface and replace it. Winds moving water. Pause. Regions dominated by eastern boundary currents have prevailing winds that blow offshore, pushing away surface water and allowing deeper, nutrient-rich water to come to the surface and replace it. Winds moving water along the shore result in a curl, right or left, north or south hemisphere, due to the Coriolis effect and Ekman transport. A perfect example is the Peruvian current. You can see the effects of productivity along the coast of South America, near the bulge on the west coast. Southeast trade winds along the shore of Peru move surface waters offshore to the west, left. This water is replaced by nutrient water from 200 to 300 meters deep. Notice that this is right below the equator, so cold water is coming up. It's replacing the warm water there. It'll warm back up again and come back down, cool off, and go back again. This area right here is the close-up of that area. And what we're looking at here is all of this productivity where the cold water has been pushed up along the side of the continent. This is the Galapagos Islands there. And no doubt, look at all the productivity around it. One of the reasons that there is so much biodiversity there. Pause. Go back to the previous slide. 1, 2, 3. Regions dominated by eastern boundary currents have prevailing winds that blow offshore, pushing away surface water and allowing deeper, nutrient-rich water to come to the surface and replace it. Winds moving water along the shore result in a curl, right or left, north or south hemisphere, due to the Coriolis effect and Ekman transport. A perfect example is the Peru current. You can see the effects of productivity along the coast of South America near the bulge on the west coast. Southeast trade winds along the shore of Peru move surface waters offshore to the west, left. This water is replaced by nutrient-rich water from 200 to 300 meters deep. This leads to high primary productivity as seen in the image and fuels a very dense community of zooplankton, anchovy, higher predators, birds, and mammals. Between 1964 and 1970, the fishery for anchovy there was 20% of the total of the world's fishery. If you look carefully, the cold water nutrients down here are going to move up, go along the coast of Peru. It is below the equator, so it's going to turn leftward, get warmed up, come back down again, cool off, and come back until it hits. That cold water has lots of nutrients in it. Here we see a close-up, and you can see where the cold water is pushed up against and gone out and away. That out and away is going towards the equatorial. This is the Galapagos Islands right here. The Galapagos Islands have lots of primary productivity around them because of the cold water moving from the coast of South America. There's no wonder that there's so much biodiversity there in the Galapagos. Island mass effects. As currents encounter island, deeper nutrient-rich water is forced towards the surface. This helps increase productivity to coral reefs. This shows the coast of Australia and the Great Barrier Reef. Shows up as high productivity specks to the east. Right in between where the red and the blue are, all of that green there is feeding the barrier reef. This image shows ocean productivity along the East Coast from Cape Hatteras, North Carolina to the Bay of Fundy. See if you can explain all of the patterns of productivity shown here. So we have high productivity all along the coast. We have low productivity out here with the Gulf Stream. The deep blue path of water running past Cape Hatteras and then offshore is the Gulf Stream. Why is the Gulf Stream so low in productivity? It's because it's moving very fast and there's little upward movement of nutrient-rich water. But why are the waters more productive near Cape Hatteras and in and near the Chesapeake Bay? Well, it's because there's areas of estuaries. The famous fishing grounds called Georges Bank is the red color east of Cape Cod. Up in here, this shows that the effects of currents dragging deep waters over shallow bottom, the bank. There are rings or lenses of low productivity water north of the Gulf Stream. This water is from the Sargasso Sea, tropical gyre water, trapped in a meander, looping curve of the Gulf Stream. They form when a meander breaks off, trapping water from the opposite side of the Gulf Stream. So why is the productivity so low there? Well, the water there is very calm. There is relatively no movement between the deep water and the surface water. This is an area that large fish come to feed.